All right, everybody, welcome to Earth Science. What we're going to ask with this lab, time for a new lab, by the way. What we're going to ask with this lab is what's the deal with the properties that affect the movement of water through soils? All right. Depending on where you live, depending on what kind of soils you have, there's times where you've maybe noticed this. Out by where I live, we've got soils that really don't let water get through all that quickly. So if we get a heavy rain, we get a lot of pooling, and our basement kind of can flood pretty easily with that too. The water doesn't infiltrate into those soils very easily. Um, like the total opposite end of that would be if you go to a beach. If you go to a beach when it's raining, or go to a beach and dump a 5 gallon bucket of water in the sand, it soaks right in very quickly, right? So what properties do we have to look at to think about these soils? This website, I'll just pick a little area here by the school and that lot across the street that's being worked on. This is where this might be of interest. If you were going to farm land, if you were going to build, um, if you are interested in having a wood lot and you want to know like what kind of trees grow better in different kinds of soils, this is the kind of information you really should be looking at. And this looks like a mess, right? This looks pretty complicated. Let's go. Let's look to the woods just beyond the football field there, IRB. So this is complicated stuff. If you look at this on a technical level, this is not necessarily like Regents level content, but just to give what we're doing some context, the idea that this is important stuff in understanding the land use, and what kind of soils you might have in an area. So like, yeah, something like this, moderately well drained. So those woods over there might drain pretty well. When I did this at my house, it did not say that at all. It said something about how it's more susceptible to pooling because of, or ponding, they call it. And instead of saying that it's sandy, it's more fines. It's more of a clay where I live. Drumlins and Till, maybe that looks familiar to some of us. So again, that's not anything that you're really going to have to get down those specifics. Should you want to go on into this field? Yes, absolutely. So what we want to get at are three basic ideas: porosity, permeability, and capillarity. And this one can kind of have another name. I'll mention that when we get there. Our setup is going to be this. And this is going to be another one of these things where you watch me. Now, this is usually a lab. This is one of the harder labs. What I usually do is I define what these three things are, and I give you a whole bunch of stuff and say, good luck, figure it out. All right. And that's a challenge. It's definitely difficult to figure that out. With all the YouTube labs this year, I'm going to be helping you through it on YouTube, for better or worse. Okay. So the idea is, now this setup is far from ideal, but what I've got is what's in this little image over here is a hose at the end of this that I can clamp off. That's put on with a hose clamp on the bottom. There's a little metal screen in the bottom to make sure beads don't get stuck in this tube. And then we've got a volume of beads that I've very carefully measured these volumes of beads this year, so that we can, I don't know, get accurate numbers. We'll see how it works. Now, there's a lot of problems with this experiment. This is significantly oversimplified. The easiest to spot problem is that we should be thinking about like the space in between the beads. What about the space in between the bead and the tube? And since this tube's so narrow and there's only like a couple of beads across, it doesn't really give us the most accurate sense of this. So our results are never perfect for this. But more important than like getting ideal results in this is going to be getting down the idea of what these three things are, what they represent. Okay, so what are they? Porosity, and yes, I'd like you writing this on your lab, is going to be how much space is there in between the beads. Essentially, that's it. So how would you measure that? How could I figure out in this tube, in this volume from the bottom of the tube to right here, how much of that is empty space? And that would be my challenge in past years, is that you guys got to come up with a lab procedure. For you guys who are so patient, I appreciate it, working through all these YouTube things. I know that it's tough. But But think about it for a minute. Could you figure out a way, thinking about a way, hint, hint, water is involved, to figure out how much empty space there is in between those beads? Permeability is an easier one. How quickly does water seep through? Okay. Now, and again, that's a key one. I did some work with farmers down towards Fabius, and they were talking about percolation tests, or essentially permeability tests, and how quickly the water comes through, and that allowed them to determine like what was a better area for. They had cattle, whether they were doing cattle or corn or feedlots or whatever it might be. They based it on that permeability idea. And those soils down there, they're different than the ones around here. Around here, again, they tend to be pretty clay bound. They tend to drain pretty slowly here in the Erie, Ontario lowlands, but other spots in the state have other properties. So this one's just how quickly does that water go through? Okay, that I bet you can figure out a way. If you sat here and thought about it for a minute, can I test the speed at which water goes down through these beads? Yeah, I could figure that out. What couple things would I have to measure to figure that out? Capillarity. Let me blow this up a little bit right here. I'm going to give another name, or retention. Retain is the root of that, if you've heard that. How much water is retained? So in other words, if I put water into here and then I take water out of here, I'm not going to get all the water out that I put in, because there's going to be little water droplets on the beads. Like you can picture that, right? The beads are still going to be wet. Well, what's their capacity for retaining water, for holding on to water? And what we'll do with all three of these is run the whole experiment 3 times, once with big beads, once with medium beads, and once with small beads. And then we'll see, okay, between big, medium, small, is there a difference in how much space there is in between the beads? Is there a difference in how quickly the water seeps through? And then capillarity, is there a difference in how much water gets held onto? I don't think that's proper English, but don't already. All right, how much water gets retained or held onto by the beads themselves? Okay. Then we'll talk about the capillarity thing eventually. If you've ever spilled some water onto something and then put a paper towel in it and seen how the water can like fight gravity and go up the paper towel, that's capillary action. That has to do with capillarity, which has to do with retention. So we're literally going to keep it easier. Just put some water in, take some water out, and as long as we know those 2 amounts, we can figure out how much got stuck to the beads. Okay, so yes, it's a little bit of a heavy lab. However, this year, instead of you having to figure it all out and write out procedures, this was usually like a week's worth of work. We're going to keep it simple. I'll shoot through these things with 3 different bead sizes. I might even be nice and pre-do the graphs for you before. I guess I have to now that I said it. It's on YouTube. So I will pre-do the graphs for you, because these can be a little bit time consuming. I'd rather get us going here. And then we'll compare our results. We'll say, here's what we got in this lab. And then I'm going to say, here's how it really should work. Sometimes we can get this to work, but again, this equipment is not ideal for necessarily demonstrating how it should work. And then some questions about aquifers and water soaking in. And if you drink well water, this is also potentially something you'd want to understand. So yeah. That should be most of it. That's our intro. So what I'll do is a couple of different videos for the different sizes. We'll get ourselves going here, and you guys are going to do great. Thanks for keeping up. We'll talk to you soon.